it doesn't matter what we do today to reduce greenhouse gas emissions, the projected climate change in the 2020s and 2030s is already governed by the actions of the past, the historical emissions. By the 2090s, it's very dependent on the greenhouse gas emissions. As you can see, as you go from low emissions to high emissions, you get redder and redder, hotter and hotter projected. And indeed, if we keep to high emission scenarios, we will see a world where, say, Africa will be typically 4, 5, 6 degrees warmer. And by the time you get to the high latitudes in the northern hemisphere, anything for 6, 7, 8, 9 degrees warmer. So the climate of the 2020s and 2030s is already preordained. But what we do in the future definitely governs the decades of the 2050s, 60s, 70s, 80s, and 90s. We saw a very hot summer in 2003. In fact, somewhere between 20 and 30,000 people died in Europe because of the hot summer. It wasn't the daytime temperature that typically killed people. It was the fact that the evenings and nights were all hot and they could not cool down. And so it was the socially disadvantaged, those that didn't have air conditioning, those that couldn't get out of the heat. And so that particular year is here. And indeed, it's right there, and it is clearly a hot year. But it'll be a very average year by the 2040s, and it'll actually be a very cool summer by the 2060s. So what was viewed to be an extreme event a couple of years ago will become normal within a few decades, and it will actually become a cool summer literally within the next 50 years. Precipitation. In some ways, you could argue for agriculture, for ecosystems, at least or more important. Much harder to project with any accuracy. The models vary from one to another, but the general picture, and on the left-hand side, it's December, January, February. On the right-hand side, June, July, August. It's for a middle scenario, middle greenhouse gas emissions. So the general picture is wetter in the high latitudes of both hemispheres and across the equatorial belt, but much drier, the red colours and the yellow colours, in the subtropics of both hemispheres. What does this mean? It means that runoff, a crucial issue for agriculture, will decrease in literally every major food bowl of the world, a major factor for food production, and therefore potentially a major factor for food security. Now, food security is not just productivity. Food security is access to food, availability of food, and affordability of food. But production of food is a key issue because it's related to availability. So clearly we have a key issue. The reason we have dry areas is twofold. One, in those areas, less precipitation, but two, hotter temperatures for more evapotranspiration. The combination of those two leads to much drier conditions. So what about the UK? Well, we use the Hadley model to try and look more probabilistically at climate. This is the 2080s. It's the medium emission scenario. And what we said to ourselves is, well, look, if you got the central probability, the 50%, what would the UK look like? Well, most of the UK would be warmer, between 4 and 5 degrees Celsius, and some parts in the south and southwest, 5 to 6, even 6 to 7 degrees Celsius. That's the medium scenario. The high scenario is more like 10 degrees Celsius. But that's the central estimate. But we looked at the probability distribution. There's uncertainties in the Hadley model. So we did 400 runs to understand all the uncertainties in the model, the way we dealt with clouds, the way we dealt with aerosols, the way we dealt with the uptake and release of energy in the ocean. We also compared the Hadley model to all the other 11 big GCMs in the world to try and look at structural differences between one model and another. And we came up with what I call a probabilistic projection. At the bottom end, if we're lucky, it's the 10% part of the probability distribution. It might only be warmer by 1 to 2 to 3 degrees Celsius. At the 90% level, here, we could be warmer by up to 10 degrees Celsius in the annual average. In summer, it's even worse. So there is a 10% possibility of this. 90% probability less, but there's at least a 10% probability of that. And therefore, there's even some chance of being higher than that. On precipitation, very top, And obviously these colours do not project at all. They're actually very vibrant on my screen. They clearly don't project at all. The basic message, because you probably can't see it, is there's not very much change in annual precipitation in the UK. However, in the winter it will become wetter, and typically the central projection, which you can't see in light blue, is between about 10 to 20% wetter. In the summer, in the central projection, it's typically about 20 to 30% drier. In the extreme, the 90% point, 10% chance of it happening, could be 70% less precipitation in southern UK. So you have a combination potentially under the medium emission scenario of 10 degrees warmer and 70% less precipitation. We have to avoid that world. So why do we care about human-induced climate change? Best period of my life was living in Southern California, where it was never much less in the summer than 90 degrees Celsius. Even in winter, in January, you could have a barbecue because it was still 60 degrees. A very, very pleasant climate. But why do we care? Major implications for agricultural productivity. Almost certainly any warming will decrease, and it already is, agricultural productivity in the tropics and subtropics, adverse impacts on fisheries, therefore potential implications for food security. Decreased water availability and water quality in many of the arid and semi-arid areas, and increased risks of floods and droughts. And in fact, the perversity of it is in one geographic location, because we'll see more heavy precipitation events and less light precipitation. In one geographic location, we're going to have both more floods and more droughts in the same year. Not good for any ecological system, managed or unmanaged. Major adverse effects on ecological systems, especially coral reefs, loss of biodiversity, almost certainly at the genetic species level. Human health issues, increase in both vector, waterborne diseases, heat stress mortality, threats to nutrition in developing countries, and adverse effects on human settlements, flooding, coastal erosion, sea level rise. On food security, major successes at one level. We've seen an increase in food production of almost a factor of 3 globally in the last 45 years. Food production per capita is higher today than it's been in the last 45 years. Food prices in real terms are an all-time low in the last 45 years, except the last 2 years where there has been a spike in food price, and I'll touch upon this. Boy, what major success. But 1 billion people go to bed hungry every night. So this is the problem. Uneven distribution of the benefits of the Green Revolution, and indeed the productivity increase throughout the world has come at a major environmental cost to our soils, our water, to biodiversity and climate change due to the emissions of greenhouse gases from the agricultural and forestry sector that add up to about 30% of all greenhouse gas emissions. This shows you some of the implications of our agricultural output. In Asia, a major increase. That's why we have far less both poverty and hunger in China today. But in the bottom here, sub-Saharan Africa, we've actually got less food produced today than 20 or 30 years ago. There's been an increase in hunger and an increase in the poverty level in sub-Saharan Africa. The Green Revolution was meant to be a major bonus, especially in India, and it was. It stopped major famines in the 80s and in the 90s. But what this shows you, those dark areas, and they actually do show up at dark, this one at least shows, in the middle of India, is where 50% of children under 5 are still undernourished. And in fact, even the lightest brown colour, which pervades India, is where 30 to 40% of children under 5 are still malnourished, undernourished. This clearly cannot be viewed as success. Why did we see a food price spike in the last couple of years? Poor harvest due to variable weather, major droughts, 9 of the last 10 years in Australia, possibly related to human-induced climate change. Increased use of biofuels, using maize in America for bioethanol, absolutely dumb policy. Increased demand, especially in China, especially increased demand for meat. High energy prices, high fertilizer prices, speculation on the commodity markets, export bans to protect domestic markets from large exporting countries. That's why we saw a food price spike. Every one of those 6 issues will be with us for the coming decades if we don't deal with them now.